Hello again. Back in June, I started working on a GyroCompass build because I had been watching a number of videos going back and forth between flat earthers and globe earthers. And some people were confused with how this could even be possible on a rotating Earth, and they didn't think that it even worked. I did start my build, and I kind of took it one step at a time. And I got as far as working on the horizontal gimbal, and I encountered a few challenges that I will probably expand on in one of the videos coming up. But this is a good video here, the horizontal gimbal, to show how applying a torque on the gyrocompass or the gyroscope in the various axes has on the gyroscope itself, and how the gyroscope itself wants to realign itself to counter that particular torque. When I got to this point, I wanted to test whether or not it was even sensitive to the Earth's rotation. And of course, there's too much friction and it's not massive enough to actually be able to resist the Earth's rotation. So it really could not counteract the rotation. But I also noticed while I was waiting for this thing to do something that the speed of the motor kept fluctuating up and down. So at this point, I kind of stepped back and tried to just work it out in my head what the various problems were. And recently, there have been a number of videos again making the rounds about gyro compasses. And Bob the Science Guy has just put out another video in response to somebody from FE Core. But I decided to go back and continue this build to try to get something working. And the next thing that I tried to do was to isolate the variation of speed that I was hearing from my earlier tests. And so I did a little bit of research, and not surprisingly, the brushed permanent magnet DC motors, which is what I'm using, it's the cheapest ones that I have. And if you get into something that's a little bit more elaborate, that has feedback and is more an induction motor, you're getting into a lot more electronics and circuitry just to get it to operate. And so the only one I had available at the time was the brushed permanent magnet DC motor. And of course, that happens to be one of the worst ones available for that. They do explain why there is some variability in it, but not here. And I'm sure that I could do some research and find out why. So I decided I was going to try to work it out for myself and to explain it on my own without doing any research further than this. So, to give you a quick overview of a permanent magnet brushed DC motor, you have permanent magnets that are the stator, so they don't move, and they're attached to the housing of the electric motor. Inside, the part that rotates, the rotor, has coils of wire, and they're attached to a commutator. Now, the commutator is what is used to transfer the electricity or the power from the brushes up to the windings. And the brushes are made out of probably some kind of soft graphite-like material. And I've got two competing explanations why the speed changes constantly. So the black part here represents the brushes. The gold part here kind of represents the commutator, and you can see a kind of like a brown ring around it. I think that brown ring represents this part here, which would be bits of the brush material that has kind of worn off and have stuck to the commutator. So I kind of see two possible scenarios as to why it would speed up and slow down. So the first explanation I can think of is that as the commutator is turning around and is scraping against the brushes, parts of the brush will wear and stick to the commutator. And it'll be kind of like, if this is pavement, this is kind of like maybe gravel a little bit. And it'll have little air pockets. And it won't be a solid, dense material like the brushes. And the resistance of this layer on the commutator will be higher than the resistance of the brush itself. So as it rotates, I suspect one possibility is that this layer will get thicker and thicker over time until it reaches a point where it gets so thick that when it finally comes around the next time, the leading edge of the brush will kind of start scraping off some of the old material, and it'll then get thin again and lower in resistance, allowing more power to go through from the brush to the commutator and to the winding. So that's one possible explanation. And it should be positively correlated, where the thinner the material, the less resistance, and therefore the greater amount of power going into it. So you would expect to see a higher current and a faster speed. The other explanation I can think of is that there are little particles of brush that get caught between the two commutator bars. And what happens is it'll probably end up creating a bridge between these two commutator bars and effectively lowering the resistance as seen from the power supply. But that means that more current is going directly from one side to the other and is not going to the winding itself. And if this is the case, then I would expect to see a negative correlation where the higher the resistance, the slower the motor turns. So in any event, the motor that I have is not suitable for this because the speed is constantly going to be going up and down based on either of these two scenarios or maybe both together. And the variability will probably, all other things aside, want to cause this thing to wander on its own, which is not related at all to the Earth's spin. So as far as I'm concerned, I would have to think that whatever I could build with the manufacturing equipment that I have available at my disposal will not be able to let me create a gyrocompass that is sensitive enough to capture the Earth's rotation. But having said that, I did spend the last little bit trying to finish the first iteration build. I might possibly try another version. That's going to be for a later video. In the meantime, I just want to give you a little bit of a teaser for what I was able to do, and hopefully you're going to look forward to that video when it finally comes out. So for now, I just wanted to point out the speed variability of a brushed permanent magnet DC motor, and as far as I'm concerned, it would not particularly be suitable for this particular application. So if you like this video, I'd appreciate a like, a subscribe, a thumbs up, all that good stuff, and leave comments below. Hopefully I'm going to see you again in another video soon enough on this very subject. So bye for now.